third vertex. These are the vectors pointing from the vertices of the face and at the fourth point in the middle of the face. Now we can create the cross product of the vector 2 with the vector 3, another cross product of vector 3 with vector 1, and a third cross product with vector 1 and vector 2. What we are doing in this case is calculating the normal vector of the sub-triangles, which also gives us the area of the parallelogram built by those edges. Half of that area would be the area of the small triangles. To calculate the area, the first area is going to be the length of the first cross product divided by 2. The second area, the length of the second cross product divided by 2, and the third area, the length of the third cross product divided by 2. Now we can calculate the normal vector of the actual face using the cross of the second vertex minus the first vertex and the third vertex minus the first vertex. This is basically taking two edges of the face and calculating the cross product, then normalizing it. Having this normal vector, we can check the angle between the cross products we calculated before for the small triangles and the actual face normal. We take the dot product, normalize the first cross product, and we dot with the normal of the face. The second angle is the second cross product, dot product with the normal, and the third angle is the third cross product, dot product with the normal. We are not calculating the inverse of the cosine function because we don't really care so much about the angle itself. We just want to detect when the sign is flipping. That means if the area of one of the triangles is negative, then the order of the vertices has been changed and the face normal has flipped its sign. We want to detect the cases when this point leaves the area of the triangle and defines a negative small triangle area. Now we can check if the angle 1 is different than the angle 2 and angle 1 is different than the angle 3. In this case, we can say that area 1 is actually negative, because we cannot have two triangles negative at the same time. If one of the three is different than the other two, we can assume that it's a negative area and flip its sign. If the angle 2 is different than the angle 1 and the angle 2 is different than the angle 3, then we can flip the sign of the second area. And if area 3 is different than 1 and area 3 is different than 2, we can flip the sign of the third area. Now, we can calculate the full area by adding area 1, area 2, and area 3. If one of those areas is negative, it's going to be